Good morning, ladies and gentlemen. I'm here to show you how to complete problem 872, part A through F. First of all, the directions talk about wanting to see if these two are correct, if they are truly equal to each other or not. First thing that asks you to do is to expand each original expression to prove that it's correct. So that is what I'm going to do, making sure that I'm writing out in expanded form and seeing if both sides are balanced to each other. All right, ladies and gentlemen, I have factored them all out. A to the third times y to the second times x to the fourth. Expanded out. Same thing with x to the seventh, y to the second. When we use our associative property and regroup these, there are 7 x's and 2 y's on both sides, so this is correct. They are equivalent or equal to each other. Problem B, expanding out. 2 to the third times 2 to the fourth. I get 2 to the seventh, not 2 to the 12th. Remember, when you are multiplying, your bases are the same, you add your exponents. So it's 2 to the 7th times 2 to the 12th, not equal to each other. Problem C, expanding out, 7 squared times 8 to the third over 7 to the third times 8 squared. Using your giant 1, anything that is the same in the base, numerator and denominator becomes a 1. With that, I'm left with 8 and 7, numerator and denominator. Yes, this one is correct. They're equivalent to each other. Problem D. Looking here, 3 to the 5th expanded out times 3 to the 2nd, and then this is 9 to the 7th. Remember, when you have your bases the same, you do not multiply them. The base stays the same. So this side is 3 to the 7th, where this is 9 to the 7th. So this one is incorrect. They're not equivalent to each other. Problem E, 6 to the 2nd over 6 to the 5th. Using our giant 1, I can remove this 6 over 6 and this 6 over 6. So on my numerator, I'm left with just 1. There are no more 6's. Remember, these are 1s times 1. And on my denominator, I have 3 6's. So this is 1 over 6 to the third. That does not equal our 6 to the third. So this is incorrect. Our numerator becomes a 1. And problem F, z to the third over z to the third. Does that equal 0? Once again, expanding it out, z times z over z times z times z. Remember, using my giant 1 here, move my camera down a little bit, my giant 1, this removes z over z becomes 1, z over z here becomes 1, z over z becomes 1, so this is 1 over 1 or 1, which does not equal 0. Remember, if you are removing these 0 pairs, these giant 1s, you're left with 1, not 0. Thank you.